Hello students, today we will discuss about our new topic integration. In the previous two lectures we were discussing about the differentiation of the functions, but today we will discuss about the integration. Let's start it. Okay, integration it is the reverse process, reverse process of differentiation. It is the reverse process of differentiation. In the definition, we have cleared that the integration is opposite to that of differentiation. So, while studying the integration, we have to consider differentiation also. So, we are going to discuss the integration with the help of differentiation. Okay, firstly we will discuss the differentiation, and after that we will take the integration of the same functions. Okay, let's see. At this side I am writing the differentiation, and at this side I am writing the integration of the same functions. Okay, let's take we have the simplest type of differentiation, that is d by dx of x raised to power n, and it will be equals to n x raised to power n minus 1. Here we can see that the power is multiplied to the function, and it is reduced by 1. Okay, now let's see what happens in the integration. I am taking the integration of same function x raised to power n. This symbol represents the integration of x raised to power n with respect to x. Okay, when we were integrating x raised to power n, it will be equals to x raised to power n plus 1 divided by n plus 1 plus in constant of integration c. Here we can see that in the differentiation we were reducing the power, and power is multiplied by the function, and in case of integration we were increasing the power of the function, and the power is divided by the function. So it is completely opposite to that of the differentiation. Okay, here the term c represents the constant of integration. So constant of integration, but there is no constant of differentiation in the differentiation. In case of differentiation, let's talk about this constant. Suppose if you are differentiating a function like dy dx of x square plus 2x plus 3, we have 2x plus 2. Okay, we have 2x plus 2 because the differentiation of x square will be equals to 2x, and the differentiation of 2x will be 2, and 3 is constant quantity. So differentiation of constant quantity will be equals to 0. While considering the definition, the integration is the reverse process of differentiation. If we apply integration on the 2x plus 2, then we have to obtain the same term uh, x square plus 2x plus 3. Let's see, if you are integrating 2x plus 2 with respect to x, then we have 2 same as it is because it is a constant quantity. Integration of x, here the power of x is 1, and 1 according to formula we add 1 power, and the same with the same power we will divide the our function plus 2. Here we can write in place of 2, 2 cross 1, and 1 can be written as x raised to power 0. So 2 can be written as 2x raised to power 0. So x raised to power 0 plus 1 divided by 0 plus 1, it will be written in this form. And if you are not writing the constant of integration, then the result will be equals to 2x square by 2 plus 2x. Okay, 2 cancels out here and x square plus 2x. But according to the definition, integration is the reverse process of differentiation. Means if we have differentiated a polynomial and the result is again integrated, we again gets the same polynomial. But in this case, when we are not considering the constant of integration, then we don't have the same polynomial as we have taken in the differentiation. Okay, so here we take a constant of integration which represents the quantity 3. For finding this value of constant of integration, we have to take the limits, and when we take the limits of integration, then the integration is known as definite integration. When there is no limit is given, limit means here we were given some quantities like from a to b, means to say we have to integrate the given function from a to b. Okay, this type of integration is known as definite integration. Okay, so this is some basic about the differentiation and integration, how integration and differentiations are linked. Now let's take some more integrations linked to the differentiation. Next one is differentiation of log of x is equals to 1 by x, and integration of 1 by x dx will be equals to log of x plus constant of integration. Same case, differentiation of sine of x is equals to cos of x, and the integration of cos of x dx will be equals to sine x plus c. We can see that in differentiation of sine is cos and the integration of cos is sine. Okay, now the differentiation of cos of x is equals to minus sine x, and integration of sine x dx will be equals to minus of cos of x plus c. Okay, next the differentiation of tangent x is equals to secant square x, and the integration of secant square x dx is equals to tangent x plus c, and the differentiation of secant x is equals to secant x tangent x, and the integration of secant x tangent x dx will be equals to secant x plus c. So we can see from these formulas that x raised to power, differentiation of x raised to power n is nx n minus 1, and the integration of x raised to power n dx is equals to x raised to power n plus 1 divided by n plus 1. And similarly, integration of 1 by x is equals to log of x plus c. Integration of cos of x is equals to sine of x. Integration of sine x is equals to minus of cos of x. Secant, similarly, the integrations for secant square x and secant x and tangent x. We have some more integrations of the functions like cosecant and cot of x. Differentiation of cot of x is equals to minus cosecant square x. Okay, and the integration of cosecant square x dx will be equals to minus cot of x plus c, and the differentiation of cosecant x is equals to cosecant x, it will be minus cosecant x cot of x, and the integration of cosecant x cot of x dx will be equals to minus cosecant x plus c. Okay, these are the some formulas for the trigonometric functions. Okay, integration of trigonometric functions. Now we will take the example of exponential function. Differentiation of exponential x is equals to exponential x. Same formula is applied in case of integration. Integration of exponential x is equals to exponential x plus, there is a difference that here a constant of integration comes with the integration of exponential x. Okay, now let's take one more term. If you are given with the term a raised to power x, differentiation of a raised to power x means here a is constant and x is variable. We have given a term containing constant power variable, then the differentiation of this function will be equals to same a raised to power x log of a. Okay, if we have to integrate the same function, then it will be reverse like previous ones. Integration of a raised to power x dx will be equals to a raised to power x divided by log of a plus c. Okay, these are the formulas that we have to use while doing the integration and differentiations. I have written both simultaneously. Okay, hope you guys understand. Let's take some examples on the basis of this formula. Suppose we have a polynomial and we have to integrate it. Suppose it is given that x cube plus 2x square plus 3x plus 5. We have to integrate it with respect to x, and the limits of integration were given from 1 to 2. Okay, limits of integration were given from 1 to 2. We will use here the simplest formula by using the formula integration of x raised to power n dx is equals to x raised to power n plus 1 divided by n plus 1 plus c. But here we are using we are doing the definite integration, so there is no need of constant of integration. Okay, let's solve the integration. It will be equals to x integration of x raised to power n. Firstly, we have to take integration on the separate terms. It will be equals to integration from 1 to 2 x raised to power n x raised to power 3 dx plus 2 can be taken outside, integration of x square from 1 to 2 dx plus 3 1 to 2 x dx. Similarly 5 integration of dx from 1 to 2. Okay, integration of x raised to power 3 will be equals to x raised to power 3. One power is added, 3 plus 1 is equals to 4, and we have to divide the same term by the power. Here the power is 4, so it will be divided by 4, and the limits are from 1 to 2 plus 2 x square will be equals to x cube divided by 3, because one power is added in this power and we will divide the same the term by same power, plus 3 integration of x will be here power of x is 1 and 1 plus 1 2, so here the integration of x will be x square by 2, limits were from 1 to 2 plus 5, and integration of dx will be x. Okay, dx will be x. Similarly, the limits of integration. Now we have to put the limits of integration. The constant terms we can take outside. 1 by 4 can be taken outside. To put the value of limits, we have to first put the upper limit in place of x and minus lower limit. Okay. Firstly, we will put upper limit. So we have 2 raised to power 4 minus sign, and after that we will put the lower limit 1 raised to power 4. Okay. Similarly, plus 2, 1 by 3 can be taken outside. It remains with 2 raised to power 3. In place of x we will put the upper limit, minus in place of x we will put the lower limit. Okay. Plus 3 by 2. Here we again put the upper limit in place of x, 2 square minus 1 square. Next one, plus 5, 2 minus 1. Okay, so 2 raised to power 4 will be equals to 16, and 16 minus 1 raised to power 1 is 1. 16 minus 1 it will be equals to 15, so it will be equals to 15 by 4 plus 2 by 3 into 2 raised to power 3 will be equals to 8. 8 minus 1, 7, and 7 multiplied by 2 will be equals to 14. So we have 14 by 3 plus here 2 raised to power 2 will be equals to 4. 4 minus 1 is 3. 3 into 3, 9. So we have 9 by 2 plus here 2 minus 1 is 1, and we have 5. So after we can take LCM from there, and from there 12 is the LCM. 4 3s are 12 and 15 3s are 45 plus 4 56 plus 6 4 54 plus 60, and it will be equals to 4 10 6 6 and 5 15 7 12 17 and 4. It will be 21 by 12. It is our answer, 215 by 12. So it is the simplest form that we have discussed about the integration. Here we were using the formula x raised to power n is equals to integration of x raised to power n is equals to x raised to power n plus 1 by n plus 1 plus constant of integration. Let's take some more examples. Okay. Suppose we have to find the integration of secant square x dx, secant square x dx from 0 to pi by 4. Okay, here the limits of the integrations are 0 to pi by 4. We know that the integration of secant square x is equals to tangent x, and the limits of the integrations are 0 to pi by 4. So we will put firstly in place of upper limit. So we have tangent of pi by 4 minus tangent 0. We know that tangent pi by 4 is equals to 1 and tangent 0 is 0. So we have answer 1. Okay. This is the integration of secant square x dx with respect to x from 0 to pi by 4, and it will be equals to 1. Okay. Now take some more examples. Let's find. Uh, Suppose we are given with an integration of, we have to integrate 1 by v with respect to v from v1 to v2, and it will be equals to, we have already discussed that the integration of 1 by x dx will be equals to log of x plus c in case of indefinite integration, but here the limits are given, so it is a definite integration. So integration of 1 by v dv will be equals to log of v, and the limits were from v1 to v2. Put the limits one by one. Firstly, we will put upper limit log of v2 minus log of v1. Okay, and we have some formulas in case of logarithmic function. If you are given with log of m plus log of n, then the formula will be log of m n, log of m n, and in place of upper form we are given with log of m minus log of n, and it will be equals to log of m by n, and if we have log of m raised to power n, it will be equals to n log of m. Okay, so here in our question we will use the second formula. So log of v2 minus log of v1 will be equals to log of v2 by v1. It is the answer of the function we are having here. So these are the some simplest integrations that we are discussed today. In the next lecture we are going to discuss integration by parts, and I am giving some hint about the integration by parts. When we were discussing about the differentiation, we were given with two functions which were multiple in the form of multiplication of each term. So we use the product rule for the differentiation of the functions. Differentiation of uv, it will be equals to differentiation of u v as it is plus differentiation of v u as it is. Okay, so similar cases here in case of integration. For solving such kind of integration, we will use integration by parts, that will be discussed in our next lecture. Thank you. Have a nice day.